again, me here. Okay, right, so we just going to have like the second lesson. It's going to be much shorter, so don't worry. Oh, by the way, okay, I didn't tell you in the first video, when I write something on the board, so it's just like in class, okay, I'd like you to copy that into your books, to make notes. I thought about sending PowerPoints, and then you can just have it digitally stored, but no, I want you really to write it in your books. I think the action of actually writing it makes you a little bit more active, and then you have a better chance of understanding it. And by the end of it, when we come back to class, hopefully in 2 weeks or maybe a little bit more, then we will you will have everything in your book and not just in somewhere in the computer on your phone. You need it on your books. Okay. Now, saying that, if I remember correct, we did write it already. But just check in your book. Check in your book if we made all these pictures of all these electron cells. Just check that. If we have it, you don't need to copy it. If you do, if you don't have it, please write it down. Okay, so what we're going to do today is we're going to look at ionic compounds. Where did we end in the last video? We realized that all atoms want to have full outer shell, so they gain or lose electrons. In other words, they become ions. Okay? If they lose electrons, okay, like sodium, magnesium, they become cations. They lost negative charge and electrons, so they become positively charged. Okay? Anions, okay, like oxygen or fluorine, they gain electrons, so they gain negatively charged. So what I'm going to add now is how we draw it. How we have like a symbol for an ion. What does that mean? Let's start with fluorine. Fluorine, okay, I don't have here, but you can look at the periodic table, is in column 7. That means he needs one more electron, right? So he will gain that electron. He won't be he will be a negative charge. Okay, so we're just going to write a minus. Okay, hopefully you can see there's a little minus there. Okay. Now oxygen, he's got 6 in the outer shell, so he needs 2 more. So he'll get 2 electrons. So he's not just going to be negative charge. He's going to be 2 minus. Okay, he's going to have a charge of -2. We usually write 2 minus. Sometimes they write -2, but normally we write 2 minus. Okay? So that means 2 minus means he had 2 extra electrons. Okay? Now, sodium, okay, he's got 1 electron in his electron shell, in the outer shell, so he's going to want to lose it. So he's going to be positively charged. Okay? Magnesium have 2 electrons that you want to get rid of them. You will get rid of them, and then it will be, yes, you got it, 2 plus. Just like oxygen is 2 minus, magnesium is 2 plus. You can see that this is plus. Okay? So this is the first bit that I want you to learn in this section, is how do you draw the symbol from the ion, for the ion. Okay? They're not atoms anymore. They're not, this is atom, but they're not neutral atoms. They are ions. Okay? But this is really just the beginning. Because, for example, let's take sodium. Okay? Let's take sodium here. Sodium, okay, wants to have a full outer shell. So it becomes a positive ion, a cation. So he got rid of the electron. But what happened to the electron? Did it just floats in the air? No. Okay? What he's going to do, he's going to look for somebody to give that electron. Okay? He's not going to just chuck it away. He's going to look for another element who might want an extra electron. And do we know of another element that would like an electron? Yes. Here we go. You know, fluorine. Fluorine wants exactly 1 electron. So for sodium meet a fluorine, okay, we can look, the way I'm going to write it is not like perfect for chemistry grade 10 and onward, but for now for grade 9 is fine. So if a sodium meet a fluorine, okay, we'll draw it like that, what will happen, okay, the sodium will give an electron to the fluorine. He wants to get rid of electron, he wants to gain electron. And then they're going to form, okay, and the sodium will be a positive ion, and the fluorine will be a negative ion. And then what will happen is, okay, if I have a positive charge and a negative charge, we already learned last year what happens to them. Yes, you remember, they get attracted. Okay, so what's going to happen is we're going to have an ionic compound. Okay, it's going to become sodium fluoride sodium fluoride. Okay? So together we made our first ionic compound just by pure thinking. And that amazing thing, it does happen in nature. Okay? You've got these compounds in nature. Okay? That's what we call a salt. Not like the salt we eat, but when you have a metal and a non-metal together, we call it a salt. Okay? And now we understand why. Because metal wants to give an electron, non-metals want to gain electrons. Together they make a good pair. Let's look at another example. So let's say we have same sodium, okay? So our sodium here, and now he meets an oxygen. Okay? Again, I'm doing some things in chemistry that I shouldn't really be doing here. Like I can't really write oxygen on its own. Yeah, you even learn that. But for now, just to kind of understand, we'll just do it. Okay? Right. So the sodium, okay, have one electron to give, and he's going to give that to the electron. Okay? But is that enough for the oxygen? No, because oxygen needs 2 electrons. He's in this period, column 6. So he's going to have another sodium come closer together. Okay? Another sodium that will give him 1 more electron. So now we've got 1 oxygen, we're going to have 2 sodiums. Okay? So I'm going to write this little kind of transition stage. Again, chemically, you shouldn't really write like that, but it doesn't matter for us now. We're going to have 2 sodium ions. Each one has a positive charge, plus 1 oxygen, which is 2 minus, and they will form us another compound. It's not going to be NaO, it will be Na2O, because we have 2 sodium atoms on 1 oxygen. Okay? So sodium oxide is not going to be NaO, it will be Na2O. And you remember that we spoke about that earlier in class, that I think, what were the examples that we were looking at? What did we burn? Magnesium, okay, MgO. We had MgO, which was without any 2, and then we had one compound that had a 2, and I can't remember which one it was. SO2. No, that's something. I can't remember. There was another one that had a 2, and I can't remember which one it was. But now we're starting to understand why you have sometimes a 2 and why not. Okay? I'm going to show you one more example. Okay, one more example. Right. So let's say now I've got Mg. Okay? And I'm going to try and react it to oxygen. Okay? This is what we've done, isn't it? Magnesium or oxygen. Magnesium has 2 electrons to give. And oxygen luckily wants to get 2 electrons. So that's fine. We just need 1 atom of magnesium and 1 atom of oxygen. Okay? So what we're going to have is magnesium 2 plus, oxygen 2 plus. They together will form MgO, magnesium oxide. Okay? I'm going to just show you one last one. Hopefully you have enough space here. Okay? What happens if I've got magnesium that wants to connect or meets up a fluorine. Okay? Now fluorine or magnesium has 2 electrons, right? So you're going to give 1 electron to 1 fluorine. How many fluorine wants? Only 1. But you still have 1 more to give. So what will happen? Yes, you're right. Another fluorine will come. Okay? So we're going to have to meet another fluorine here. Okay? Because you never have just 1 atom of fluorine. You'll have lots. Okay? And then you're going to have magnesium 2 plus you got 2 fluorine. Each one have a negative charge of 1 minus. And that's going to form MgF2. Now the 2 is on the non-metal side. Okay? And that is called magnesium fluoride. Okay? We already learned last year, it's not called magnesium fluorine, magnesium fluoride. It becomes always oxide, fluoride, chloride, iodide. Okay? But for the first time in your chemistry career, you're starting to understand why sometimes there's a 2 and 1 there's not. Okay? That will be enough for today, for this week. Okay? Next week, we're going to get into a bit more complicated. where we have threes and all kind of complicated stuff. But for now, I just want you to practice on these simple ones. The worksheet that I've asked you to do, you will see it. Okay, I've asked you to do these 2 worksheets. This one, have no problem there. This one will be a little bit more difficult, but after this lesson, I think you can manage. Okay, if there's any problems, just ask me on WhatsApp, and I'll help out. Okay, as I explained on the OneNote, I'd like you to do both worksheets, but the electron shells one, I want you to actually write it down or add it into your homework folder on OneNote. Okay, and you can just, I think the easiest thing is just to write on a little piece of paper, WhatsApp it, and then put it on OneNote. Actually, you know what? Forget about it. Easier. Just go onto your homework folder and just type out the numbers. You don't need to copy the whole sheet. Just write down the answers. I'm just asking you to do that so I can see that you got it. Okay? Memos will be put by the end of the week. Have a lovely day, guys.